Good evening all. We will start question number 17 today. So what is the question given means find the values of a and b. The function is given here. If x is less than or equal to 3, that is ax plus 1. If x is greater than 3, the value of the function is f of x equal to bx plus 3. The function given, it is continuous at x equal to 3. So it is continuous at x equal to 3 means at x equal to 3 LHL equal to RHL. So what is LHL now? LHL at x equals to 3. So now limit x tends to 3 minus f of x equals to limit h tends to 0 f of 3 minus h. So f of x, in this case the value of f of x equals to f of x is less than 3 case, that is ax plus 1. So f of 3 minus h value equals to a into 3 minus h plus 1. Now apply the limit for that. Limit h tends to 0 f of 3 minus h is equals to limit h tends to 0 a into 3 minus h plus 1. Applying limit, we will get h equal to, applying h equal to 0, we will get 3a plus 1. So my LHL is equals to 3a plus 1. So what about the RHL at x equal to 3? At x equals to 3, the RHL, definition of RHL is limit x tends to 3 plus f of x is equals to limit h tends to 0 f of 3 plus h. So in this case, what is the value of f of x? X is greater than 3 case. So greater than 3 case, f of x value is equals to bx plus 3. So what is the value of f of 3 plus h? F of 3 plus h equal to b of 3 plus h plus 3. Now apply the limit. Limit h tends to 0 f of 3 plus h is equals to limit h tends to 0 f of 3 plus h value is b of 3 plus h plus 3. Now applying the limit h equal to 0, we will get 3b plus 3 is the right hand limit. So already we know that f of x is continuous at x equals to 3. So at the point x equal to 3, LHL is equals to RHL at x equals to 3. So I am going to equate this 3a plus 1, that is equals to 3b plus 3. Clear? So now I am simplifying this. So I can write this 3a minus 3b equal to 3 minus 1. So I can take common 3. So a minus b is equals to 2. 3 times a minus b equal to 2. So a equal to 2 by 3. So the value of a equal to b plus 2 by 3. So this is the relation between a and b. Clear? Okay, next question. Question number 18. Question number 18. For what value of lambda is the function f of x is given? That the function f of x is given here. This function lambda into x square minus 2x, where x is less than or equal to 0, 4x plus 1, x is greater than 0. So for what value of lambda this function is continuous at x equal to 0, and second one we have to check the continuity at x equal to 1. So we are going to find the value of lambda if this function is continuous at x equal to 0. So if it is continuous at x equal to 0, f of x is, if f of x is continuous at x equals to 0, then LHL is equals to RHL at x equal to 0. This already we know. So now we will find the LHL of the function. So what is LHL? LHL at the point x equal to 0. LHL at x equal to 0. Write the definition of LHL. Limit x tends to 0 minus f of x is equals to limit h tends to 0 f of 0 minus h. So we want to find the value of f of 0 minus h. So what is the f of x in this case? Less than 0 case, equal to less than 0 case, f of x value is lambda into x square minus 2x. Now what is the value of f of 0 minus lambda h? 0 minus h is equal to minus h. So lambda times substituting x in the place minus h mean this will be h square, this will be 2h. So now apply the limit for this. Limit h tends to 0, f of 0 minus h is minus h, that is equals to limit h tends to 0 lambda into h square plus 2h. So applying h equal to 0, you will get 0 as our left hand limit. So left hand limit equal to 0. So what about right hand limit at x equal to 0? Right hand limit RHL at x equal to 0. So in this case, what is the value of f of x? F of x value is greater than 0 case. Greater than 0 case, the value of lambda value of f of x equal to 4x plus 1. So now apply the right hand limit definition. So limit x tends to 0 plus f of x is equals to limit h tends to 0 f of 0 plus h. This is the value. So what is the value of f of 0 plus h? That is f of h equal to 4h plus 1. So now f of h equal to 4h plus 1 means find the limit. So limit h tends to 0, f of h is equals to limit h tends to 0, f of h equal to 4h plus 1. Applying h equal to 0, that is equal to 0. So my RHL equal to 1. So my RHL is equals to 1. So LHL equal to 0, RHL equal to 1. So we can say that clearly RHL never be equal to LHL. LHL not equal to RHL for any value of lambda. So it never be equal. So we can therefore we can say that clearly f of x is not continuous. F of x is not continuous for any value of lambda at x equal to 0. So second case, what is given? What about the continuity at x equal to 1? So we are going to check the continuity at x equal to 1. I am going to check the continuity at x equal to 1. So I need to find the left hand limit and right hand limit at x equal to 1. So here left hand limit is equal to what? Left hand limit LHL at the point x equal to 1. Clear? So now definition of left hand limit I am going to write here. So limit x tends to left hand limit, so 1 minus f of x is equals to limit h tends to 0 f of 1 minus h. So in this case f of x, what is the value of f of x? Less than 1 case. Less than 1 means greater than 0 case, for all the value it is 4x plus 1. So less than 1 means 0.9, 0.99, very the value very close to, very near to 1, also 4x plus 1. So my f of x equal to 4x plus 1. What is the value of f of 1 minus h? That is equal to 4 times 1 minus h plus 1. Now find the limit. Limit h tends to 0 f of 1 minus h is equals to limit h tends to 0 f of 1 minus h means 4 times 1 minus h plus 1, that is equal to, applying h equal to 0 means 4 into 1 plus 1, 5 will come. So LHL is equals to 5 will come. Similarly, right hand limit at x equal to 1. So right hand limit at x equal to 1, that is limit x tends to 1 plus f of x is equals to limit h tends to 0 f of 1 plus h I need to find. So f of 1 plus h value, before that what is the value of f of x? Greater than 1 case, greater than 1 means 1.1, 1.01 are very close to 1 but greater than 1, that is also equal to 4x plus 1. So 4x plus 1. Now apply the limit. Before that, find the value of f of 1 plus h. F of 1 plus h is equals to 4 times 1 plus h plus 1. Now limit h tends to 0. F of 1 plus h is equals to limit h tends to 0. F of 1 plus h value is 4 times 1 plus h plus 1. So applying h equal to 0, same 5 we will get. So my RHL is equals to 5, LHL also 5. So I can say that LHL is equals to RHL, that is equal to 5. Here it is independent of 5. This 5, both LHL and RHL also independent of lambda. So I can conclude that LHL is equal to RHL equal to 5 for any value of lambda. For any value of lambda, since or therefore I can say that f of x is continuous at x equal to 1 for any value of lambda. Actually previous case it is not continuous for any value of lambda. This case it is continuous for all value of lambda, or we can write instead of any value we can write for all values of lambda. Here also we can say that for all values of lambda. Clear? Next question, question number 19. Very important question this one. Question number 19. Before entering into that, we have to know the definition concept. We have to know the greatest integer function x. So this is called greatest integer function. We have to write that greatest integer function. Greatest integer function less than or equal to x. So what is the definition of this greatest integer function less than or equal to x? Actually, for example, if I am taking 1.2, so the value greatest integer function of 1.2 means the greatest integer less than or equal to 1.2. So equal to 1.2, there is no integer, so we have to check what are the integers less than 1.2. So less than 1.2 we have the integers 1, 0, minus 1, minus 2, etc. Among all these, greatest integer is 1, so whose value equal to 1. Similarly, I can take 1.9. So greatest integer of 1.9. So 1.9 means equal to 1.9, there is no integer. So less than this, what are the integers will come? 1, 0, minus 1, minus 2, etc. So among all these, what is the greatest integer? 1. So whose value equal to 1. Suppose what about for negative numbers? For example, greatest integer of minus 0.9. So minus 0.9 means equal to minus 0.9, there is no integer. So before into that we have to plot this minus 0 point in number line and check, it will be very easy to understand. So this is my 0, minus 1, minus 0.1, 0.2, 0.3, it will be minus 0.9. So minus 0.9 equal to minus 0.9, there is no integer. Less than this, what are all the integers are available? Minus 1, minus 2, minus 3, etc. Among all these, what is the greatest integer? Minus 1. So minus 0.9, greatest integer of minus 0.9 equal to minus 1. Similarly for our remaining value. So generally how we will write that means, generally we will write the definition as, for example, greatest integer of x is equals to 1 if value of x is lies between, that is greater than or equal to 1, less than 2. Similarly, greatest integer of x is equals to 2, that is x value will be greater than or equal to 2, less than 3. That is from 2 to 2.9999, the whose greatest integer value equal to x. Similarly, greatest integer of x is equal to 0. X value is greater than or equal to 0, less than 1. Greatest integer of x is minus 1, whose value is x value is greater than minus 1, less than 0. So all the values it will take minus 1. This is the definition of greatest integer function. Now we will come to the problem number 19. What is problem number 19 given? So that the function defined g of x, so the function given g of x equals to, the function g of x is equals to x minus greatest integer of x. So g of x equal to x minus greatest integer of x. This function is discontinuous at all integral points we need to show. So it is discontinuous at all integral points means integer points. So integer points, for example, we know that all the integer points x is equal to 0, plus 1, minus 1, plus 2, minus 2, all these integer points we have to show that it is discontinuous. So discontinuous means what? At all the integer point g of x value is all the integer point g of x left hand limit and right hand limit at all integer points not equal, we need to prove. For example, we need to show that let x equals to a. So x equal to a, because we have infinite number of integer points, so I am proving generally x equal to a. What is the condition for a is a equals to, a belongs to the integers. Left hand limit definition, limit x tends to a minus f of x is equals to limit h tends to 0 f of a minus h. So what is the definition? So here we have taken g of x, so we will change the function into g of x. So g of a minus h. So what is the value of g of x here? G of x equal to x minus greatest integer of x. So replace x in the place a minus h. So g of a minus h equals to a minus h minus of greatest integer of a minus h. Clear? Now we are going to find the greatest integer of a minus h. So just see this case, h value equals to very near to 0. That is very near to 0 means it may be very near to 0 means h may be equal to 0.1 or 0.01, very small value, h is equal to very small value. So I am taking, for example, h equal to 0.01. So now what is the value of greatest integer of a minus h? For example, this is my a in the number line, this my a. So a minus h means this value equal to 0.01. The a minus h will be just close to a left side of a, that is a minus h. Now I am going to find the greatest integer of a minus h. For example, I am taking a equal to 5 means my a minus h will be 4.99. So greatest integer of this 5 equals to, that is greatest integer of 5 equal to, we know that 5, greatest integer of that a minus h we need. So greatest integer of 4.99 equal to 4. Suppose I am taking 5 means I am getting 4. Suppose I am getting, instead of 6 I am taking. So what is the value of a minus h? A minus h will be 5.99. So whose greatest integer value equals to 5. So similarly, if I am taking a, my a minus h will be left side of the a. So greatest integer of a minus h will be 1 less than the a. So I can conclude that my a minus h value, that is greatest integer of a minus h value is a minus 1, that is 1 less than a. Now multiply minus inside, a minus h minus a plus 1 plus a minus a will be cancelled. 1 minus h value is the value of g of a minus h. Now apply limit for that, limit h tends to 0, g of a minus h is equals to limit h tends to 0, g of a minus h is equal to 1 minus h. Applying limit I will get 1. So my LHL is equal to 1 at x equal to a. What about RHL case? RHL case RHL at x equal to a I am going to find. So the definition of RHL is limit x tends to a plus f of x is equals to limit h tends to 0. We are using g here, so we can use g of x. Limit h tends to 0, g of a plus h. So now what is the value of g of x? G of x equal to x minus greatest integer of x. So substitute now g of a plus h means we will get x minus greatest integer of a plus h. Now we will find the value greatest integer of a plus h. Again plot the a in the number line. We know that h is equal to very smallest values. I am taking 0.01. So my a plus h will be very close to a but right side of a. In this case I will get right side of a, my a plus h will be there. For example, if I am taking a means 5 means my a plus h will be 5.01 whose greatest integer value is equals to 5. Suppose I am taking a equal to 6 means my a plus h will be 6.01 whose greatest integer value equals to 6. So at all the cases, if I am taking a, the same a value is my greatest integer. If I am taking 6, 6 is my greatest integer. So my greatest integer value of a plus h, that is equals to a. So that I am substituting here. So x minus a. Sorry, x value already we know we have to apply a plus h. So replace that also, that we will get it a plus h minus of a will come. So the minus a plus a will get cancelled. We will get that g of a plus h equal to h. Here also replace that a plus h. Clear? So now apply the limit. Limit h tends to 0. G of a plus h is equals to limit h tends to 0. G of a plus h value is equals to h. Applying limit, we will get that is equal to 0. So my right hand limit, that is equals to 0. Left hand limit equals to 1. So that is RHL. So LHL is not equals to RHL. Left hand limit is not equals to right hand limit. Therefore we can say that f of x is not continuous at which point? At x equal to, here we have taken a, so x equal to a, it is not continuous. What about a? A is an integer. So therefore also we can say that f of x is not continuous at all integral points. At all integral points. Clear? Thank you. Next class we will see the question number 20, 21, 22. Thank you.